Hello and welcome to ROS 101, a fun approach delivered to you by Samurai. Today we will have a quick recap on what we did last time. We so far learned to create publishers and subscribers, and we talked about that architecture and that it resembles like the power of teamwork and client-server packages, which are more oriented towards hit-and-run tasks. Where a client hires a server to um, execute a specific task through a request, and then it receives a response from the server, which elaborates on the execution of the task. Was it successful, for example, and what feedback you could provide on the execution of the task. And now we're somehow familiar with the basic ROS utilities. Most of the utilities we use so far are the utilities that are used by programmers and experts to deliver or create the ROS packages. So you're pretty much, familiar with all or most of the details that make a good ROS programmer. So today's agenda is we're going to discuss some ROS utilities like the ROS Parameter Server, which stores the parameters that we need for our code. And the easy way to describe this is that we have some constants that we basically need in our code. So ROS can store these constants or parameters for us, and we're going to learn how to do that. And we also have something called a ROS bag, which kind of stores something for us, and we're going to discuss what it stores and how it stores it. And then we'll have quick exercises in both of these utilities. All right, so let's dive in. So the first thing we're going to discuss today is the concept of the ROS Parameter Server. And what a ROS Parameter Server is, it is, something that is associated with the ROS master or the ROS core, and is responsible for storing our constants or parameters. So what we need to learn is how to manipulate this ROS Parameter Server by adding some parameters, by reading some parameters maybe, and stuff like that. So first thing we're going to do is that we're going to open up a terminal, and we're going to use a command called ROS param list. And as far as we know, anything that includes list means make me a list of the current ROS parameters that exist now, and ROS topic list, make a list of the available ROS topics, and so on and so forth. So whenever you want to list something or show something, you just use the type of ROS object that you have, for example, ROS param or ROS topic or ROS message or stuff like that, and then followed by the name list. So I'm gonna, just list the parameters that are here. So these are the parameters that are currently available on the ROS core. And I got the ROS core working in another terminal, so I need to close this one. This is an old terminal here, and I need to rerun the ROS core. First of all, you always need to run the ROS core first. You cannot use any ROS command without running the ROS core first, especially that we said that the ROS Parameter Server is linked to the ROS core. So I started the ROS core. Now I'm going to say ROS param list again, in order just to have a clear version of the current available parameters. So yeah, we have a less number of parameters here because I ran a new ROS core that excluded all the parameters that I already used in in some old program that I was running before starting the tutorial. So these are the parameters that you will usually find whenever you start a new ROS core. So let's, for example, investigate one of these parameters, see what it encompasses or something like that. So let's just type a command called ROS param get. And what ROS param get does is it gets the value inside this parameter that we need to investigate. So let's just investigate this ROS distro parameter. So I'm going to copy it. And one important thing is don't forget the slash. whenever you use ROS topic or ROS topics or ROS messages or stuff like that, you always need to include the slash, because sometimes when you forget the slash, sometimes the program will run just fine and sometimes it will display an error. It just differs according to, you know, whether you're running it on the terminal or in a script and stuff like that. So just to keep ourselves on the safe side, we'll always use the slash before the name of the topic or the parameter. So when I got the value stored inside ROS distro, we find neotics. So we can deduce that this ROS distro parameter is, you know, the distribution of our ROS version, or our ROS distribution, which is currently running on our machine, which is neotic. Alright, that's good so far. So what if we want to add a new parameter to this ROS parameter server? So let's just type ROS param help, which is short, H short for help. So what this command does is that it basically just explains what this command is all about. So it says ROS param is a command line tool for getting, setting, or deleting parameters. And you basically can do that for any other command as well. For example, ROS topic h, that's going to provide help on what ROS topic is. So it's kind of a help tool. So anyway, let's get back to the ROS parameter help. So I've got set and get and load and dump and delete. So let's just stick to set and get right now. So what we need to do is to set a new parameter. So how am I going to do that? I'm going to type ROS param, then the name of the parameter that I want to add. Let's just call it Sam, for example. Sam param. I like the rhyming. Alright, and let's give it the value 1. And by the way, I forgot set. ROS param set. So now we have this parameter stored in our ROS server, but we need to check whether it's really there. So I'm going to type ROS param list, and there it is. We can find it here, and we can also get its value. So we're going to type ROS param get Sam param. And yeah, it has the value 1 and it does exist. So this part is perfectly done. So what we need to do now is, you know, so far we manipulated the ROS parameter server through the terminal. What if we want to manipulate it through coding? And this is a more automated or an automatic version of our work, because the user is not supposed to load parameters from the terminal while the program is running. The program has to run with a ROS launch command, for example, and that's it. That's what all the user has to do. So in order to make this more compatible with the user needs, we're just gonna, you know, create something called AM file. And the AM file is basically a database for all the parameters of your projects or all the constants that you need. So let's open our Catkin workspace and let's head to the pub/sub package, for example. Alright, so I think I made this config file. Well, we saw before that we had a file called scripts, which includes the codes that we wrote, and the launch file, which is responsible for the launch files, which in turn just launches a number of nodes at the same time or simultaneously. So what we need to do now is to add a new folder called config, which is the folder I just deleted, but I deleted it in order to, you know, let you see me create this folder from scratch again. So the config file is the configuration file, and it includes all these YAML files, which are supposed to include our parameters. So for scripts, we got the Python scripts. For launch, we got the launch files, and for config, we got the YAML files. So we need to create this YAML file. What I'm going to do is that I'm going to open a new terminal, which is located within this directory or representing this directory, and I'm going to say touch, for example, sam param. Let it be param sam, because we already have a parameter called param sam or sam param. Let's call it param sam. I don't know what I'm doing. Just fine. All right, touch param sam, and yeah, it has the extension YAML because this is a YAML file. The same thing goes for Python files. We got an extension called .py, and for launch files, we got an extension called .launch. But here, this is a YAML file. So here's my YAML file. All right, and what I want to do now is to add a couple of variables here. So we had a variable called, sorry, not variables. Let's just call them constants or parameters. Let's stick to the terminology here. All right, so I'm gonna redefine samparam here. And the way I'm going to do that, well, basically in programming, you just say samparam is equal to, for example, let's change the value and let it be 2. But when it comes to a param file, this is not a Python file, so the coding kind of differs. And here, I just place a colon instead of the equal sign. And you'll find that the color changed, indicating that this is, this is a sound code. Alright, and let's define another parameter called samparam2, for example. And we're going to give it the value 3. So if this program or this YAML file was loaded correctly into our parameter server, we will find that our samparam constant changed its value from 1 to 2, and we have a new constant called samparam2, which has the value 3. That is, if everything went fine. So that's pretty much it for the YAML file. It's pretty straightforward and pretty easy. All you have to do is just determine the name of the variable and then a colon and then the value, right? So let's get back to PubSub, and we're gonna ask ourselves the question: how am I gonna run this YAML file? I mean, for Python files or for nodes, you gotta use ROS run, and for running multiple nodes at the same time, you gotta use a ROS launch. So for configurations or for YAML files, you can't run a YAML file individually. You have to run it through a ROS launch command. So it has to be included within your launch file, right? So within a launch file, you can have, or you can load or launch both nodes and parameter files or YAML files. So what I'm going to do here is that I'm going to, create a new launch file, for example. So we had an open terminal here, so let's get back to this directory and let's get to the launch directory. So now we're located within the launch directory. So I'm gonna create a new launch file and I'm gonna call it, for example, paramsam, the same name, because it's gonna only load some variables. So I'm just gonna call it the same name as the YAML file. And since they have different extensions, so there will be no confusion between the two files. They have the same name but not the same extension. The problem would occur if they have the same name and the same extension at the same time. So here it is. We got the launch file. So what I'm basically going to do is I'm going to use the XML commands that we were introduced to before, but for launch files, for launching or loading parameters, it's kind of different from the launching of nodes. So we got a line which launches nodes, which was composed of first the keyword node, and then the name of the node, and then the type of the node, which is basically the name of the Python file where the node is located, and then the package name, and then the output, which was basically the screen. But here we'll have some differences. So first of all, the similarities are we have launch here, and we have slash launch here. Just the beginning and the end of my launch file, and these do not change. But we need to now type the line which is concerned with loading the parameters. So what I'm going to type here is, first of all, alright, let's pretend for a second that I forgot that I have to type ROS param, because this is the keyword that is located at the beginning of the line. So actually the whole line is ROS param, and then I'm gonna defines some property called the command, and this command is equal to load, which means load my parameters into the parameter server, and we've got the file name or the file location in this case. Well, we've got the location which is home and then summer, because this is the name of my machine, and then Catkin workspace. You can cheat the directory from here because it is written here. So Catkin workspace, and then PubSub, right? But pay attention to the fact that this is the launch file directory. We need the config file directory. So I'm just gonna cheat by just going here. So now, now I have, I can cheat the whole location. All right, so it's home summer, and by the way, this is just the home of my machine. It has to be written that way, right? Because, for example, let's just say I want to move out to this particular directory. So what I have to do is to type cd. Here in the terminal, you can type tilde in to shorten this this path or this internal URL within your computer, but we're not allowed to do that in launch files. So I'm going to display it on the terminal first, and then we're going to get back to the launch file. So in case I want to go to this directory here, what I'm going to do is change directory, and then catkin workspace, and then src, and then pops up, and then config. Alright, so I'm there, and I can also use cd home summer catkin workspace src pops up and config. That's quite the same thing. It will deliver the same result, but we have to use this one here in our launch file. So I'm going to use that, and we got pops up and then config. And lastly, the name of the file itself, which is param.sam.yaml. And then I'm going to just, close with a slash and an arrow. And let's just say I forgot, for example, the ROS param keyword. Whenever you forget something, and this pretty much happens, whatever your experience is, you gotta navigate to, for example, the ROS wiki, right? So I'm gonna type ROS wiki and launch, for example, I'm gonna type that, and it's gonna direct me to the page where it explains, how to use launch files, right? So here it is. So this is how to launch a node, and we need to launch, for example, some parameter here. ROS param, for example. This is a tag reference, and it's going to give you examples on how to use ROS param, which is pretty much what I typed just now. Right, so whenever you forget something, you can just use the ROS wiki, and it's not embarrassing to do that. I do that all the time, right? So now we're done with the YAML file, so let's try to run it. I think this terminal is used for creating the file, so I'm just going to close this one. I'm going to get back here. And I think I'm done. I got the YAML file. I think I got the launch file as well. Yeah, the param.sam.launch. We just wrote it. Yeah, everything's set. So let's launch this file and see if our parameters are indeed loaded. Right, so ROS launch, and the name of the package, which is pops up, and then the name of the launch file itself, which is param.sam.launch. So something went wrong. It says the file does not exist. So maybe you typed the wrong name. We got the param.sam.yaml. Alright, so let's get back to the launch file here, and let's check if everything was right. So we loaded home summer ROS param command is equal to load, file is equal to home summer catkin workspace, pops up, config param.sam.yaml. So everything seems to fit so far. I don't know why I displayed that. So it says that the file does not exist. Right, maybe I did something wrong here. Yeah, it's the same name. Everything seems to fit. Maybe I copied something wrong. So yeah, problems happen. It's good actually that we ran through a problem so you could see how we usually get through that. So we did pub sub and config. Yeah, its directory is fine. So let's add the rest, pub sub, and then config, and then param samblium, or just config. So there's no such file or directory that, oh yeah, I forgot this one. Also no such file or directory, so that means I typed something wrong. So this one went fine. Home till Catkin workspace. Oh yeah, I forgot the src. So after Catkin workspace, there is src, which includes the whole packages. So yeah, that was the error. So let's try it again. And there we go. The command supposedly ran. So let's check if these parameters indeed exist. Yeah, we have samparam and samparam2. Let's get one of their values, for example. Let's check if samparam changed, for example. So I'm going to type ROS param get sam param. Yeah, it has the value too. So the value indeed changed. One last trick I'm going to teach you is that, well, you can either just type the whole directory address here, which is pretty tedious, first of all, and second of all, whenever you try to give your package to someone else, or whenever someone downloads your package, for example, and gets to run this command, well, our machines are different, and our names are different, and the locations of our packages are located within different workspaces. So maybe his workspace is not called Catkin workspace. Maybe his machine is not called Sammer. So he'll have to change this command. So I'll have to navigate to the file and just change the directory. And this is not, this is not a good migration. All right, so this is not a good practice, and we need to, make it more flexible. All right, so what I'm gonna do is, I'm just gonna, change the whole thing, right? So up until the package name, right? And I'm just gonna type a new command called $find pubsub. What this does is that it constructs your machine or your ROS Parameter Server to, look for this package wherever it is, right? So it might be anywhere. He just continues to search for it, or it just continues to search for it till it finds this package. And as long as this package is contained within a workspace that has been sourced by your bash RC or by your terminal, then it's gonna find it. So let's try it out now. And alright, let's relaunch this file again. So indeed it was launched, and let's get samparam2, for example. And indeed, well, it ran fine, and it's pretty flexible now. We don't have to go there and change this address once more whenever a user changes or whenever a machine changes. So that's it for the ROS Parameter Server. So the second part of our tutorial handles ROS Bags, and what ROS Bags are, as the name suggests, they're bags for storing your data or storing your outcome coming out of the project you're creating, and that means we're trying to record the data that the topics have, or the messages that the topics include. And this is pretty useful when you have like a troubleshooting issue or something that you need to monitor, or some value or some variable that you need to monitor during your experiment. For example, for fault detection, if your robot is navigating, for example, through some environment, and suddenly the robot begins to lose track of its current location, for example, or hits the wall or something like that. So it's useful to have some sort of a log file that includes all the data on the robot, maybe the sensory information, for example, to figure out what went wrong. And for example, you might find that a sensor was malfunctioning and starting to produce wrong values, for example. So it's pretty useful to have some sort of a log file to elaborate on the issue. So what we're gonna do is we're gonna open up a terminal as usual, and then we will create a topic using the terminal. We created a topic before using the script, but for now I just want to to create a quick topic. So I'm gonna type ROS topic pub, and this is a new command that means publish. Then I'm gonna give the topic a name. Let's just call it Sam, and then I'm gonna determine my message type. So I'm gonna use standard messages, and maybe, for example, int16, like an integer. And last thing is I'm gonna include the data itself, which is 1, for example. Oh, I forgot the master as usual, so I have to include the ROS score. And then I'm gonna type the command again. So ROS topic pub, the topic name, and then the message type, and finally the value. So yeah, that basically created a topic that would just produce one message, and or a publisher that produces one message to a topic called Sam. So let's make sure that this topic exists. So ROS topic list. And indeed, we have a Sam topic, and we can echo it to see what it holds. ROS topic echo Sam. Right, so it has one piece of data, which is 1. Right. So that's pretty good so far. And what we need to do now is to create something called a bag file. So what we did so far is that we created like launch files, we created YAM files, and we created Python files. What we need to do now is to create a bag folder. So I'm gonna head back here to my Catkin workspace, and I'm gonna go to the source file, and then I'm gonna get to the pub/sub, for example. Alright, I made a bag file already. So let's just repeat that again. I'm gonna open up a terminal here, and I'm gonna create a new folder. So I'm gonna say make directory bag. So we get a new folder here called bag, and again, this is just a convention. You don't have to do that, but it's better if you do that if you have like some sort of folder for each application. So scripts for Python files, launch for launch files, config for YAM files, and bag for ROS bags. So I'm gonna get here, and I need to create a bag here. Alright, so we created the bag file. What we need to do now is to create the ROS bag itself, which is the file that would include our data eventually. So let's just close the old terminal here. Let's close up the ROS score and this stuff. Yeah. So let's start with this new terminal here. What I'm going to do is that I'm going to repeat the same steps once more. So first of all, I'm going to create a ROS bag file by typing ROS bag record. And what this does is that it creates a ROS bag and it starts to record some topic, right? So I'm gonna give a name, and that name will be the name of the topic that I want to record. So in this case, it's Sam, for example. The topic does not exist yet because I closed the old terminal, and I did kill the processes that produce the messages of this topic. But again, the ROS bag would still be active and waiting to record the data once the topic becomes available. So yeah, that's it. Again, I forgot the master. That's what 4 hours of sleep do to you. Right, so ROS core. And then I'm gonna open up a new file here. Yeah. Alright, yeah. Alright, so I'm gonna start the ROS bag again. So ROS bag record, and I've got the name of the topic, which is Sam. Yeah. So yeah, the bag started. Alright, so we have an active bag, but we need to have a topic in order for this bag to listen to. So we're gonna do the same steps as before. ROS topic pub, and the name of the topic, Sam, and then the type of the message, which is standard messages, and int 16, for example, and we're gonna press 1. And yeah, it is publishing, and the bag has something to listen to. All right, and we can make sure that the topic is indeed there and producing the data we want by ROS topic echo that topic again. So yeah, the topic does exist, and the bag has recorded what it has, or what it has to offer. All right, so I'm just gonna kill these processes. All right, the reason we don't see the bag here is probably because it's located in the home directory. And no, it's located somewhere. Well, it's located where the directory was. So here we had, yeah, in PubSub itself. So I'm gonna go to Catkin Workspace and src, and then PubSub, and we find that the bag was here instead of here because I forgot to include the terminal within this directory, because the terminal was, or the command itself, which is the ROS bag record, was typed within the directory, which is PubSub. I was supposed to navigate first to the bag directory and then record my data. So no problem, I'm just gonna get this to be here. All right, and you could notice that we have a date here, or a timing for this file, or this this file is named using the date that it was created on. But I'm just gonna use test bag. All right, test. Let's call it just test. So we've got our test bag here, right? So far so good. Right, so this bag is supposed to include my data, but of course it's encrypted. You can see zeros and ones, the file logo here, so it's probably encrypted and we can't access it right away. So how can we read the content of this bag file? So we can pick an option, which is the terminal, as usual. So we can play back this bag. And what we're going to do is that we're going to use a command called ROS bag. Right, before we do this command, or before we execute this command, we might start an echo here. ROS topic echo for Sam. And of course, this ROS topic will not echo anything because Sam is already killed and the topic does not exist anymore. But what I want to try here is to play back this bag so that the SAM topic can exist once more through the records of this bag. So what I'm going to type here is ROS bag. Alright, let's navigate to the folder first. So let's cd bag. Right, so we're here and we need to play back this bag. So I'm going to type ROS bag play, and we're going to play the bag that we have, which is this bag. Right, and it's done. So let's see here. Yeah, indeed, there was a topic that was called SAM, and this topic was created through the playback of this test bag file, and we received the data on this topic, so everything is just going fine here. So that's one way of doing it, using the terminal. But what if we want to make a script? Or what if we want to like read the contents of the bag using a script instead of using the terminal? So this is, this is also available. Alright, so I'm gonna head back to PubSub and I'm gonna go to scripts, and we want to create a script that could read the bag content. So let's close this terminal, I no longer need it, and let's open a new terminal inside this directory, and we're gonna use the touch command to create a new Python file. I'm gonna call it touch read bag, for example, the py. Right, and we're back to creating nodes once more. So I'm gonna open up that, and I'm just gonna execute the usual tasks. I'm gonna pick a user environment, which is user bin environment, and I'm going to use Python 3, and I'm also going to import rosby, and this time I'm importing something new called rosbag, of course. Right, and then we might think of the rest of the code. So first of all, I need to like initialize this node, so rosby.init node, and I'm gonna call it just read bag. Alright, so far we used all of this stuff, and I'm gonna create a bag object. So a bag object is much like for example, the publisher object and many other objects that I've created before. So it's created through a command basically. So I'm gonna say bag is equal to rosbag. Remember that when it was publishers we're dealing with, we said that we're going to use rosby to create a publisher, which is rosby the publisher, for example. Here makes sense to use the rosbag library, and we're going to use a property called bag, or function called bag, and then we're going to include the name and the location of the bag. So you can just type the exact location of the bag. So this bag was located in the home directory, so I'm gonna type home summer catkin workspace, and then src, and then pubsub, and then the bag was located in a bag folder, and its name was test bag. No, just test, I guess. Yeah, test bag. All right. And that's pretty much what we need so far. So how am I going to read the bag? So this bag data is like organized in a way in which there are topics, right? So we have different topics because we might be listening to multiple topics, not just one topic. And then each topic tree, for example, has messages assigned to specific times. So we've got topics, and we've got times, and we've got messages. So each message has a timestamp, and each message belongs to a topic. So what we need to do is to loop through this content. We need to loop through topics, and we need to loop through messages and times. So what I'm going to do is that I'm going to start a for loop. I think we talked about for loops before. In case we didn't talk about them, a for loop is like a loop in which you continue to execute something until a certain condition is met. Or as in this case, this loop is terminated once we have navigated through every partition of this bag file. So I'm going to type for topic, message, and time t. So these are the three variables that represent topics, messages, and times. Alright, so I'm going to loop through each one of them because it's like more, for those of you who are familiar with programming, you've heard about something called a nested for loop, for example, in which I'm looping through, for each topic, and then once you're in each topic, you navigate through, or you loop through all the messages there and all the timestamps there. So you're like looping through every detail. So for every topic, for every message, for every time, until you're done with all of these partitions, or all of these nested partitions, you're good to go. All right. So we got for topic, message t in range. All right, we're not going to use range. I'm not going to talk about range right now. Just let's stick to what we have. So we're going to use a command here called bag.read messages. So what this command does is that it's just a command for reading bags. That's all. So it just brings up all the content of the bag, but in its original form, like topics, times, and messages. So if I try to print it, all of it, it's just gonna be, we'll have some readability issue for the user. We want to type messages and their timestamps, and we might want to focus on a specific topic, not all topics, because if we hear all topics, there's a crazy number of topics running once you start the ROS course. So we need to focus on some specific topics, and this is why we're creating this for loop. And we'll see that we get to see that once we get to the body of the for loop itself. So I'm going to use this command, and I'm going to determine the topics which I want to listen to. So I'm going to say topics, and I'm going to pick the name of the topic that I'm going to use, which is SAM in this case, for example. But if you have many topics, so you'll just create a list, and what a list is, it's like an array of multiple components, or containing multiple strings, variables, whatever. So it's like a collection of variables instead of just one variable. All right, so for example, let's listen to Sam and Jenny, for example. Right, and John, for example. Right, and we close up the list by including the other, bracket. So a list is contained within brackets, and there are commas separating our different variables or different components or different strings or whatever. In this case, it's strings because topics are defined using strings, but we have only one topic here, so I'm going to use Sam. All right, and right now I need to, for example, if we have multiple topics, you need to include an if statement, because you need to, if you have too many topics and you want just to focus on one topic, you're going to type if topic, for example, and topic is this variable. So it's a variable that determines which topic I'm currently focusing on. So let's just say I'm going to focus on Sam. I'm going to print the content of Sam. All right. And if topic is equal to Sam, then I'm going to print the message, and I'm gonna print the time of this message, or the timestamp of this message, which is the variable representing the time. All right. So many of you would think, why would I just determine the topic here and then write an if statement that uses the same topic? It's not reasonable. But in case you have multiple topics, you might need to print all the messages and times that are related to some topic, and then repeat this if statement again, because you want display all the contents of the first topic, then the contents of the second topic, then the contents of the third topic, and stuff like that. So I'm just using it on one topic here, so it doesn't really make sense, but once you have multiple topics it will make sense. Alright, so I guess that's all. What I'm gonna do now is I need to make this work. So I'm gonna use my terminal, and this time I'll not forget the ROS score. And then I'm gonna open up a new tab, and then I'm gonna run this ROS bag file or read bag file. So I'm gonna say ROS run and the name of the package, which is pub/sub, and then read bag .py. Oh, I forgot to make it an executable. So this is the thing with ROS, you always forget something. Alright, so I'm gonna allow executing this file as a program. I'm gonna head back here, and then I'm gonna type it again. So yeah, what we've got in this bag, what was read so far, is that we had a data, and this data was 1. So this is the message. This is the part here. Alright, I closed it. Let's open it up again. So this is the message that was printed. So if we get back to the terminal, we find that the message was indeed typed, right? And then we had the timestamp, and the timestamp looks really weird. So what's that? Actually, it is the timestamp, but it is recorded in nanoseconds. And don't ask me why it's recorded in nanoseconds. It's pretty weird, but that is what we have, right? So in order to make this more readable, we can change the code a little bit. So we might print here like a string called Sam's data is, for example. Yep. And then we're gonna type message.data, the data part of the message, because when we display the whole message and this message happens to be a composite message, then you've got a part which represents the data, for example, another part which represents the layout, for example, and maybe there are custom messages that include like X and Y and Z components like we had in the turtle bot. Well, it doesn't matter. I just want to display the data as raw data because Sam has only one data type, which is the N16 or the integer 16, so I need to display the data right away. And maybe print here. And it was, for example, recorded at, alright, and we might print t, but we might multiply t times 10 power negative 6 or 10 power negative 9 because it's a nano. So 10 power negative 9, and this is how you use the power command. This is a power command. It's like 2 asterisks because power is like some form of multiplication or multiple multiplication, so we just use like 2 asterisks while we use 1 asterisk for multiplication itself. So, and we might print like here, we might add here plus seconds, right, just to denote the unit of time. So let's try to play it out one more time. The ROS score is still active, so I'm good to go. Alright, we had like unsupported operand types for time and float. Right, maybe it was the string, I guess. So let's just print that and asterisk for time and float. Oh, maybe, oh yeah, the variable t, maybe it has a certain type that is not float, and this is why there is an incompatibility issue here. So yeah, maybe the time, this time variable here is not float actually, and this is what's causing us trouble. So let's just define, I don't know, maybe another variable here, for example, like time is equal to float. Let's try typecasting. And let's just say time here, and let's try that one more time. Alright, so our variable t is of the type time, which seems to be a custom type. Alright, we might search on how to convert time to float, but that's not our scope right now, so I'll just have to do with you know, the nanosecond version for now. But of course, there must be a way for typecasting this time variable, right, and converting it to float so that I could, you know, execute some arithmetic operations on it, like power and multiplication and stuff like that. But anyway, it doesn't matter. We'll just do with a nanosecond version we have now. So yeah, and we might add nanoseconds here just to let the user, you know, be familiar with the unit. Yeah, it's again, yeah, it's unsupported because we cannot add that to that. So if you can, you know, make it up into a list, maybe. A list can include multiple data types, so we can make it into a list called time, for example. So we could use t and nanosecond, maybe. And let's try to type time. Yeah, it's a time thing. Alright. We might search on how to convert time, alright, a time variable, because this seems to be a very special type of variable, and we need to typecast this somehow into a float, for example, or a string or something, in case we want to like convert it into a more readable format. But now we have like, right, we got that this way, so yeah. Alright, so it's implied that it's nanosecond for now, and that means it's like, I don't know, maybe I have to count like 9 from the right to the left, and then you get a stop at some point and put a decimal point there. Alright, so that's how you read your data using a ROS bag, and let's just try like having multiple topics, maybe, so we could, for example, we have a publisher.py here already, so I might use it to like create 2 publishers instead of 1. So we might copy that line, right? Sorry, and we have to call pub2, for example, just to differentiate between these 2 objects, and we're gonna call that like, let's call this one, for example, Sam. Let's call this one Jenny, right? And yeah, let's leave them to be N64 and the queue size to be the same, and we've got pub2 to publish. Right, so this one will publish 2 and this one will publish 1. So yeah, we've got ourselves a publisher node that has two topics, all right? And it's pretty cool to have two topics. You can have like 10 topics or 10 publishers in the same script, it doesn't matter. So let's just check that this one is running fine. So let's try ROS run publisher.py. Yeah, I forgot to include the package name. Alright, it's working. So let's use our old bag to record this, all these topics. So I'm gonna just, use a command called ROS bag. I'll use ROS bag help in order to, I want to find a way to record all topics that are currently running. So let's use the help. And I think we had, well, let's use ROS bag record help. There must be a way to record all the possible topics. I think it was, yeah, record all topics, which is this one. So we gotta type A. Yeah, and right, and yeah, I think we gotta use A. Record the bag with name O. Alright, so we're gonna use ROS bag record. I'm gonna use all, right? And I need a specific bag. Well, we gotta say record the bag with name .bags. So we gotta say, for example, let's copy this one, right? And we gotta paste it here. And the name would be I think it was test.bag. Let's see if it works. Alright, we're subscribing to everything, so we're currently actually recording all the possible topics that are available right now. So we've got like ROS out AGG, and we've got another topic called ROS out. So we can run our publisher.py right now. So let's run it. Right. And we'll find that our bag is currently subscribing to Sam and Jenny as well. So our bag is recording everything right now. And yeah, we'll just kill that one now. Right. And then we can kill this one as well. We recorded what we need. So our bag recorded everything, and because we had the terminal located here, because this is the directory, the bag was created here, right? This new test bag instead of the old one. So you gotta take care to just open up your terminal from this bag folder, or you can just run it anywhere and then get it from there and just copy it. Alright, so we're gonna delete the old bag that we had here. So just delete this one and get the new bag, which, yeah, it wasn't script. So let's cut it and paste it here. Let's get back to let's get back to pub sub and bag here. So yeah, we have it now, and we might run like the ROS run command maybe. Yeah, we had our core. Yeah, our core is running. And yeah, we can run it from here actually. We can run ROS run pub sub publisher.py. We can just change that to read bag.py, but we need to change the code itself because I think it was not updated so far. So let's get back to the scripts and let's open up readbag.py. Yeah, we've got only one topic here, so let's just say we need two topics, which Sam and Ginny, for example. And we're gonna these are the topics that we're interested in the contents of that bag, and we're gonna copy that and just add another if statement here. Right, if topic is equal to Ginny, then Ginny's data is message to data, and it was recorded at, yeah, that's pretty much that. Right, so let's run it again, see what we have. Right, so we got the contents of our bag printed on the terminal. So first of all, we got Sam's data, right, and Ginny's data, then Sam, then Ginny, then Sam, then Ginny, then Sam, then Ginny, then Sam, then Ginny, and yeah. So it was like taking the order of the for loop. So I'm just like looping through each topic, and then we gotta have Sam message followed by Ginny message and a Sam message, and then a Ginny's message, and that's gender equality for you, right? So yeah. That's the case in case you want to record multiple topics and you need to troubleshoot and stuff. So you gotta get through all the data here, and you gotta look at it at the terminal. In fact, there are other ways to look at the data. There are plotting tools, for example, that you could use instead of just printing data on the terminal. There are multiple plotting tools like the MATLAB plot library, for example. In case you have your bag and you want to plot the data to have a more visual sense of what's going on instead of just printing numbers on the terminal and looking like you're some operators from the Matrix movie where they look at a screen full of just green symbols and they try to make sense of what's going on. So that's pretty much what we're doing right now. So you might have some other visualization tool that you might use to record your data or play your data. So yeah, you might use multiple scenarios here. But point is, you have something called a ROS bag that you can use to record your data, and then you can play it back by using the terminal or by using a script. And in case you're using a script, you might use plotting tools, you might use other visualization tools that you might quite like instead of just using a terminal print. So yeah, that is the ROS bag part, and now it's been concluded. So let's sum up what we did today. We were introduced to the ROS Parameter Server, what it is. It's a place for storing our constants or our program parameters, and how to manipulate it using the terminal, using the ROS param commands, and using code. And by code we mean creating YAML files and then launching them through the ROS launch files, right? And we were introduced also to ROS bags and how to create them using the terminal, and also we could play back the content of the ROS bags using either our terminal or using a read script, right? So these two features here are quite useful for your ROS projects, and they are commonly used for feeding your parameters or feeding your constants for example your robot control module, which contains some parameters like the controller gain, for example, and the controller saturation limit, stuff like that. You need to feed to your code instead of just hard writing them or hard coding them into your code. You might need to make your code more flexible by including them as parameters that you gotta change by accessing the YAML file itself instead of just having to go through your code and looking for the variables or the constants that you want to change. So it's better to have a YAML file that's quite accessible to every user, where you can manipulate the parameters as much as you need, and the ROS bags are pretty useful for troubleshooting. So that's all for today.